Okay, so defining a schema. I've heard a lot of people ask questions like, how do I define my schema? Who's going to own my schema? I've got this schema. There's a notion of a type. Types are important. Types are fundamental. The thing I want to say is that it doesn't necessarily need to be a big debate. It doesn't necessarily need to be even much of a discussion. And the reason for that is that I'm going to start off by asking, what's your server language? So Facebook uses a language called Hack, which is a terrible name for a type-safe version of PHP. But the basic principles of, like, you're writing a server in a language, there's a language, principles should translate that like that. And I don't know if you've noticed by looking at different programming languages, but a lot of languages have some notion of classes and a notion of methods. But not GraphQL. That's a totally different language. Instead, it has concepts called types and fields. And what I'd like to suggest is that perhaps these are similar, and that we should make use of that. So if we look at a schema definition in GraphQL, we see something like type user. Okay, what's a user? For Facebook, users have various qualities like names, hometowns. Friends are kind of important. But at Facebook, in our native language, Hack, we also have implementations of a class that I will name for the purpose of this talk, FB user. Now you'll notice some similarities between the GraphQL schema here and the actual class, FB user. The similarities are literally the entire thing. They're the same. I've found by talking to a lot of different people that the server language that they're developing and the GraphQL types they end up exposing turn out to be extremely similar, which is to say there's almost always a class or an object that represents a GraphQL type, and the methods effectively, maybe with one or two tweaks, generate the fields for a GraphQL type. And that's because schemas are a type system. Your GraphQL schema provides types. Types have fields. Fields have types. And GraphQL is strongly typed. Now, your language might also be strongly typed. And so the schema definition I would like to suggest is something you should consider to be the bridge between your languages, or your server language's type system and your GraphQL type system. This is to say your server's implementation matters, and you should not be abstracting away from this blindly. Specifically, what I'm trying to say is that even though your client engineers are operating above the data layer, so you're grabbing some info through GraphQL, you don't need to care about what the server is doing, but chances are the server actually does care about what the server is doing, right? So at Facebook, our server actually produces a website. You can find it at facebook.com. And the years we spent developing the website for Facebook ended up producing a pretty decent API in Hack for building a website. And it turned out, broadly speaking, people writing server APIs are usually exposing the right data for the right purpose, or it's close enough that you can usually get that you can usually tie together your GraphQL type system to the actual underlying language. So what I'm going to tell you about writing your own schema is not to. Specifically, I'd like to give you a little bit of code here where, and this is the new definition format that I talked about at the GraphQL meetup in London. You can find that on YouTube if you care about that sort of thing. But if we look at a query to get information about a type on the left, it maps pretty closely, once again, to the actual implementation of what that type would be on the right-hand side. So in Hack, we have annotations. There's a Java implementation for GraphQL, I think, that also does an annotation approach to schema definition. But basically, we're saying there's this FB user class, and it represents the GraphQL user type. And there's this function called getName in the FB user class that represents the name field on the GraphQL user type. So effectively, what we're saying here is the internal server API is the GraphQL API. And now, this might not be exactly what you want, but it's actually pretty easy to just write another function that produces the code that you actually want to express. So I'm suggesting that, in fact, you don't write your own schema. You just indicate in your actual language what the schema should eventually look like. OK, so how do you actually get to a schema that looks like what you want it to look like? We use Codegen. So we've talked about Codegen on the client side a decent amount during the summit. And I'd like to talk about using it on the server side as well. Because when you've got all that code over here, you're tying things directly to other things. The server wants the flexibility to develop, to change, to do the right thing now. So what happens if the implementation changes? Well, here's where I'm suggesting that you assume that coupling is tight, that things are connected directly together, and then you don't tie them actually together. So you actually build, what we're doing is we're building a layer in between where we're generating runtime artifacts from the annotations in the code base, and those runtime artifacts are what gets used at actual runtime. So even though we can see over here that the class and the method names are tied directly to GraphQL, when we actually run things, we're running code that looks more like what's on the bottom than the code that's on the top. So the code on the bottom is generated code where we figured out based on the annotations via a build script that runs that's run by engineers as they're developing the server both for the website and for GraphQL simultaneously, because once again they're the same now. You got a simple constant for the name, for the description of a type, and then individual functions that are generated that are just named the same thing as the fields, so that when you want a field result from a runtime definition, you just call the method whose name you already know. And then the types down below, you can just generate the types in the same sort of way. This gives us something that effectively maps directly onto the schema. So in our runtime definitions here, you can see getName returns a string, just like the schema says that name should return a string. And similarly, when you get a function like genFriends, the return value for the genFriends type can be induced back and forth because we have such a tight mapping. So the runtime definition can give you the right code in your native programming language that it needs, because even though it's generated from a GraphQL schema, it's able to produce the type-safe code that you need then, which lets you ensure that at compile time, your native code is sound because your types all work together. Your actual functions are actual types. Even your runtime definitions should type check normally. But then at build time, once you've got these runtime definitions, you know that your generated code is sound. So at that point, you don't need to worry about things like validating that the correctly typed data is going to come out. You already have that because you did all of this code gen work and tying things together, which means that your schema and queries can be assumed to be sound in the first place. So at runtime, the type systems match, even though you don't have any runtime checks or guarantees that they matched, which make things a lot faster. So in sum, I'm suggesting that you not write your own schema. Just write good APIs for your server that are designed to produce what your server engineers already know how to produce, and then just say, this is my GraphQL schema on top of the individual types there. And then when you build your GraphQL runtime definitions, you're able to ensure that everything is coming out safe, even though you don't need to do as many checks. So thank you. Managed to finish 16 seconds early.